Dear students, welcome to my channel. This channel is only for you. Last class I have discussed about rational numbers, natural numbers, whole numbers, and today I am going to discuss about irrational numbers. How can you represent irrational numbers on number line? Irrational numbers on number line. How can you represent? This one number line 0, 1, 2, 3, infinity, here minus infinity, minus 1, minus 2, minus 3. So between any two integers there are infinite number of rational numbers, and there are so many irrational numbers also. For example, root over 2, root over 3, root over 5, root over 7, these are irrational numbers. Today I will discuss how can you represent irrational numbers on number line. Represent root over 2 on number line. How can you represent root over 2 on number line? First you have to draw a number line. Then you have to draw a square of side taking 1 unit. Say from here to here 1 unit. You have to draw a square of side 1 unit square. Say this one O, this point is A, this one O, A, B and C. Now join the diagonal. OB is the diagonal. So each angle of square is 90 degree. So OAB is a right angle triangle. Right angle triangle. Since OAB is a right angle triangle, therefore using Pythagoras theorem, diagonal square equal to base square plus height square. OA square plus AB square. OA means 1 unit, 1 square, this one 1 square, all sides are 1 unit, or OB square equal to 1 square 1 plus 1 equal to 2, or OB equal to root over 2. Now OB equal to root over 2, you will take a compass. Taking in this way, OS center, draw an arc. Taking compass, draw an arc in this way. And this point, say this point is P. This point is root over 2. On number line, this point is root over 2. So I have discussed how can you represent root over 2 on number line. In your book is also this one given. Root 3 is also given. You can check your book. Next, exercise 1.2. State true or false. Justify your answers. Every irrational number is a real number. Real number means natural number is also real number. Whole number is also real number. Integers is also real number. Rational number is also real number. Irrational numbers all are belongs to real numbers. Remember this one? So every irrational number is a real number. This one true. Every point on number line is of the form root over m, where m is a natural number. In number line, there are infinite number of points. This one 0, say this one 1. This part is 2 by 3. So this point is also in number line, but it is not a natural number. So this one false. You can write reasons because 2 by 3 is a point on number line, but it is not natural. It is not natural number. Every real number is an irrational number. Every real number, say 1 is also real number, 0 is also real number, minus 2 by 3 also real number, root over 5 is also real number. Here given every real number is an irrational number. This one not irrational, this one rational, this one whole number, this one natural number. So every real number is an irrational number. This one false. False. False, because or since 2 is real number but not irrational number. Irrational number. You can give another example also. Number 2, are the square roots of all positive integers irrational? All positive integers. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Are the square roots of all positive integers irrational? No. Since root over 4 equal to 2, which is not irrational. Which is not irrational. Question number 3. Show how root 5 can be represented on the number line. I have already discussed how can you locate root over 2 on number line. Same as root over 2. For root over 5, you have to draw a right angle triangle taking base as 2 units and height is 1 unit. This one 1, this one 1 unit. If this one O, this point is taking A and join this. This one B. You have to write in this way. Let us draw a right angle triangle OAB, for which OA equal to 2 units, AB 1 unit and angle OAB equal to 90 degree. Using Pythagoras theorem, OB square, OA square plus AB square, or OB square 2 square plus 1 square, or you can write OB square equal to 4 plus 1, or OB equal to root over 5. Now same as root over 2, this one root over 5, taking OS center, OBS radius, you have to draw an arc. Draw an arc with the compass, and this point P is the point root over 5 on the number line. Remember this one? So after this you have to write, taking OS center, OBS radius, we draw an arc which intersects number line on P. The point P is root over 5 on number line. So exercise 1.2 is over. I think all of you understood my class. If you understood my class, don't forget to like, comment and share. If you not subscribe my channel, then please subscribe my channel for next class. Thank you for watching.